Okay, we'll start this part of the lesson with writing half reactions for redox equations. Now, what do we have to keep in mind is that we need to write the half reactions for redox equation because we want to see which one is taking and which one is giving which one is receiving and which one is giving the electrons. So which one is gaining and which one is losing the electrons. And the half reactions are important because when we go to balancing redox equations and dealing with batteries and all that stuff, then those half reactions become very, very useful for the next step of our questions and our problems and our concepts that we will face in electrochemistry. So let's take a look at what is happening when copper is reacting with silver nitrate to form copper nitrate and silver. When we look at this from the balance perspective, then we have to have 2 here and 2 here. So now copper 1, silver 2, silver 2, nitrate 2 and 2. So this is balanced. So it always will start with a balanced reaction. Now let's identify the oxidation number for each of those parts of the reaction. So copper, since it is a single element, a free element, then the oxidation number is 0. And on the other hand, we see, since this is a single replacement reaction where copper is replacing silver, then to grab the nitrate, then nitrate stays the same. So now the charge, nitrate is one of the polyatomic, and when we take a look at the charge of the polyatomic, nitrate is a -1. So the whole thing here is a -1, which brings us into the fact that since the whole compound has to be 0, then tells us that the oxidation number of silver will be 0. Oh, sorry. The whole thing will be 0. So -1 plus this should be +1 to make it the whole thing 0. Now, when we when we see that nitrate is a -1, then since we have 2 nitrate, the whole thing will be -2, and the whole compound silver nitrate in order to be equal to 0, copper has to be 2, and silver, since it is an ion, an element on its own, will be equals to 0. Let's see and observe now what is happening with the elements that are changing the oxidation number. So what do we notice here as a very first thing is that copper from 0 is becoming copper 2+. So from 0 is becoming copper 2+, which means that from 0 charge is going to lose 2 electron 2. So it's a losing. Sorry. It's losing 2 electrons. Therefore, when it is losing electrons, what do we call it? Is we say that copper is oxidized. Okay. And now when we take a look at the other one that is changing the oxidation number, which is silver. So silver now from positive 1 is becoming 0. And from positive 1 to become 0 means that you are gaining electrons. And when you gain electrons, what we say is that we say that it is reduced. So when we are writing the half reactions, what we are doing is we are including only the elements of that the oxidation number is changing. So the first half reaction will be copper from 0 is becoming copper 2 plus. And the other one is silver from 0 is becoming, from plus 1 is becoming 0. So now in order to become 2 plus, what it means for copper 0 means that is giving the electrons away. So those will go to the product side. And when the silver is from 1 plus becoming neutral, means that is grabbing 1 electron, so plus 1 electron. So those are the half reactions that are happening in this singular replacement reaction. So what we notice here, since it is losing the electrons, then this is half reaction oxidation, and this one here is half reaction reduction. And remember what we said on the previous videos, that now copper is the reduction agent and silver becomes an oxidation agent. Let's take a look at another reaction, and then write the half reaction for redoxes. So let's see when NH3 plus oxygen are reacting, and then NO2 and water is formed. This is not balanced, but for now we will focus only on the half reaction, so we don't worry about it. Let's take a look now to identifying the oxidations number. So we'll start with NH3. So when we see the NH3, hydrogen is plus 1, and there is one exception there for hydrogen. When it is combined with or binded with metal, then it is -1, but in this case nitrogen is not a metal, so will be plus 1. And now, since we have 3 hydrogen, 3 times plus 1, in order to have the oxidation number of the whole thing, NH3 is equal to 0, then this will become -3. And then for an oxygen that is an element, then the oxidation number will be equals to 0. Now, let's move to the product side of it, and then what we have is that we have oxygen that is -2, but when it is with hydrogen peroxide is -1. So in this case, it's not the hydrogen peroxide, so will be -2. So -2 times 2 will be equals to -4, and in order to make the nitrogen dioxide as 0, we have to make the nitrogen as +4. And for water is oxygen is a -2 and hydrogen is +1 to make it equals to 0. So now let's take a look at the elements that the oxidation number have changed. And the elements that the oxidation number is changed is nitrogen. Sorry about this. I don't know why is it moving like this. So nitrogen, it's going from -3 into +4. Therefore, what is happening with nitrogen is losing electrons, so it is being oxidized. So it's going from -3, which is more electrons than protons, to +4, which has less electrons than protons. Okay, next one is oxygen. Because when you see here, hydrogen stays the same, +1, +1, so it's not the focus of our half reaction. So now the next one is oxygen, which goes from 0 to -2. So what is happening with that is from 0, that number of electrons and protons is the same, is going to -2, which means that the number of electrons is more than the number of protons. So therefore, it is gaining electrons, which means that is reduced. Okay. So now when we are writing the half reactions for nitrogen, we will have N3. It's going to become -3. It's going to become +4, which means that is gaining 7 electrons. And what it is as a reaction is the oxidation, half reaction oxidation. And for the reduction half reaction, what we have is oxygen that is 0 is gaining 2 electrons, and it is becoming O2 minus. Okay, it's gaining 2 electrons. Okay, makes sense? And this, what it is half reduction equation. However, just wait, because we have something to explain here and to take into consideration that oxygen cannot be as a O2O on his own, but it always have to be O2. So we somehow have to balance. So oxygen will become O2. We have to take it into consideration. So therefore, since oxygen is O2, still though with the same oxidation number, then everything else will be multiplied by 2. So it's the same as saying now instead of having 2 electrons, we have 2 times 2, which is 4 electrons. And instead of having 1 atom with a charge of -2, then we will have 2 atoms with a charge of -2. So the full reduction half reaction for oxygen and for any diatomic or any special diatomic, then we will have O2 plus 4 electrons is equals to, or gives us 2 atoms of 2 ions of oxygen, and this will be the final reduction half reaction for oxygen on this given equation. Now you may say, what is happening with hydrogen? Hydrogen is not even part of, it's not changing anything, so it is not part of the half reaction, either oxidation or reduction. This concludes the next part of day 1, in which we are, the last thing that we did is we saw how can we write the half reduction or oxidation reactions. And previous to that, we saw we talked about the oxidation number. We will do more examples like this in class, so please review this video on your own and then ask questions in class if you have any.